So today is our second lecture for Maths 210. In the previous lecture, we discussed some basic terminologies and introduction to this course. Where do these equations come from, and physically as well as mathematically. Today we are again going to discuss some basic terminologies and notations. And notations. Sorry. Notations. We discussed what is the order of a differential equation, what is degree of a differential equation, and what is linear differential equation. Before discussing linear and nonlinear differential equations, again in detail, first we need to define some basic notations. I told you that a differential equation is basically an equation which involves derivatives of a function. For example, d square y by dx square plus 2x dy by dx plus 9y is equal to some function sine of x, where this x should be defined for some open interval, maybe minus infinity to plus infinity on the complete real number. Then this differential equation in general, how can we define it? In fact, if we take this thing on the left hand side and we put it equal to 0, then what terms and what variables are involved in this function, in this equation? In general, we can write this differential equation into this form. It is a function of what? Independent variable x, dependent variable y, its first derivative y dash, and its second derivative y double dash, and we put it equal to 0. So in general, this equation as a whole is a function of x, y, y dash, and y double dash. So that is why we can put it in this form, f function of x, y, y dash, y double dash. Okay. Similarly, let's take another example. If we have maybe d cube y by dx cube plus x square y equal to 0. Now, this equation involves x, y, and y triple dash. But in y triple dash, y double dash, and y single dash, they are hidden. Okay. So in order to reach at y triple dash, means d cube y by dx square, first you must have y dash, and then y double dash, and then y triple dash. So in general, what do we write here? This is a function of x, independent variable, y, y dash, y double dash, and then y triple dash. We put it equal to 0. So in general, this equation is a function of all these quantities. But if someone asks me, there is no y double dash here, d square y by dx square, then even we don't have y dash in this equation. But in y triple dash, in d cube y by dx square, there must be a y double dash and there must be a y single dash. I hope you get it. So in general, this is a function of x, y, y dash, y double dash, and y triple dash, and so on. Similarly, if we have a general nth order differential equation, we can write that differential equation in this form: f of x, y, y dash, and so on, y nth derivative, means y n dash. This we put it equal to 0. So this is how we can write that differential equation if the differential equation is of order n. Okay. Another example, if we have dy by dx plus 9y is equal to 0, then equal to 0 or some other function e power x maybe, then this can be written as f of x y dash equal to 0. This is the most general notation of the differential equations. Okay, most, you can say, not more, most general, most general. I hope you get it. If you have any question, you can ask me. Now, another general form, which is also used to denote the differential equation is, for example, come back to our previous examples here. Here, in this case, can I erase it? We look for the highest order derivative in the differential equation. We look for the highest order derivative. What is the highest order derivative? This is the highest order derivative in this differential equation. We keep this derivative on the left hand side, d square y by dx square, and we take all other things on the right hand side. So we can write this thing as a sine x minus 2x dy by dx minus 9y. Okay, so here we have highest order derivative involved in that equation, highest order derivative. We keep the highest order derivative on the left hand side and all other terms on the right hand side. Then we can write this thing as it's a d square y by dx square is equal to, what is this thing? It's a function of x, y dash, and y. So in general, we can write this as a function of maybe small f, just to differentiate between the previous notation and this notation. You can write a small f of function of x, y, and y dash. So this is another notation for describing the differential equation. Generally, we keep the highest order derivative on the left hand side and all of the terms on the right hand side. And then we decide, we will look for the terms here, and we say that this is a function of x, y, and y dash. Another example, in this case, the highest order derivative is the cube y by dx cube. And all other terms may be x squared y. We have only one term. But while writing this as a function of what? It is a function of x, y, because here we have third derivative, so we have to go up to the second derivative. So it should be a function of x, y, y dash, and y double dash. Okay. So this differential equation should be denoted in general in this form. And similarly, this one is denoted by dy by dx is equal to function of x and y. Okay. If we have here first derivative, here we have zeroth derivative. If we have 3 here, we have 2 here. So on the right hand side, we always have one less derivative than the derivative on the left hand side. So here we have 2, here we have 1 derivative. So in general, another notation of the differential equation is if we have an nth ordered and nth order differential equation, or ODE, ordinary differential equation, can be can be written as dn y by dx n is equal to function of x, y dash, and so on, y n minus 1th dash. So this is how we write differential equation in another form. I hope you get it. If you have any question, you can ask me. Some other notations, dy by dx can be written as y dash. I hope you know it already. And we can also write it, और कौन सी फॉर्म होती है, dy ऐसे भी लिख सकते हैं इसको, ठीक है, dy by dx को sometimes dy by dx को आप dy भी लिख सकते हैं. Any other notation? Sometimes in physics, while using x as a displacement, अगर हायर डेरिवेटिव्स होंगे तो यहाँ पे आई होप यू कैन डी स्केयर वाई बाई डी एक्स स्केयर है, तो यहाँ पे y डबल डैश होगा, क्यूब होगा तो y ट्रिपल डैश एंड सो ऑन. So similarly here, if you have d square y by dx square, then we should write it d square y and d cube y, d4y and so on. Huh? It's derivative d by dx. D stands for d by dx. Okay, and in general, dn stands for nth derivative, dn by dx. Okay. In physics, sometimes, okay, most of the time, in physics, the differential equations are denoted differently by using the displacement function. We say that x is a function of t, where x is a displacement function. Then differential equations are usually denoted by x dot plus 2t, x is equal to some function of t, maybe sine t. So this is how they denote differential equations in physics. Okay. And if we have a second derivative, then x double dot plus 2, maybe x dot plus e raised power t x is equal to maybe x square. Sorry, not x square, t square. T square. Okay, x is dependent variable here. So x dot is what? X dot is first derivative with respect to time t. X double dot with respect to time, second derivative with respect to time t. This is how they denote differential equations. Okay. Okay. Now let's discuss linear versus non-linear differential equations. Linear and non-linear ODEs first. Ordinary differential equations. Let me try the exact definition for you guys. Degree. Yeah. A differential equation, either it is ODE or PDE. It can be PDE as well. A differential equation, it's written in my notes. You can see the proper definition. A differential equation is said to be linear if the dependent variables is linear in each term. Okay. An ODE of a differential equation. A differential equation is said to be linear if each term in the differential equation, if the dependent variable or variables, if the dependent variable and all of its derivatives, derivatives are linear in each term. Yes. Now, what does it mean by linear in each term? Linear in each term. What does it mean? Linear means one. So a differential equation, if I write these well, short notation में लिखते हैं. Y double dash plus 2y y dash plus 3y is equal to maybe e raised power x. Now look at y in each term. In the first term, y double dash is linear, is of degree 1. Okay, linear means is of degree 1. यहाँ पे इस term में y की degree 1 है. What is the degree? Degree is basically the power of y. Power of y is 1. Here, in the second term, what is the degree here? Is it linear? No, because the whole power of y, in fact, is what? Power 1 here is key, or यहाँ पे इसकी 1. So it becomes 1 plus 1 is equal to 2. So here in this term, in the second term, y is not linear. Its power is not 1. और यहाँ पे देखें third term में इसकी power 1 है. So in each term, the dependent variable and all of its derivatives, they should be linear. They must have degree 1. So in this equation, in first term, the degree is 1, or the y is linear. In this term, we have power 1 here and power 1 here. Its power is 2. It is not linear. Y is not linear. यहाँ पे linear है. So if at least in one term, अगर y की degree 1 नहीं है, तो y linear नहीं है, then we say that this differential equation is non-linear. Other examples may include maybe y double dash x square plus maybe cosine of x y dash plus e raised power x y is equal to x. Now look at this differential equation. In the first term, what is the power of y? It is 1. What is the power of y here? It is 1. What is the power of y here? 1. Okay, we look at the left hand side. The right hand side is generally the function of x only, where the function of independent variables. So on the left hand side, the power of y, or the degree of y, is 1 in each term. Therefore, this differential equation is linear. Okay. The coefficients of these y and its derivatives, they must be the functions of independent variable only. Okay, the coefficients of y and y dash, y double dash, the coefficients should be the functions of independent variable only. The coefficients or the coefficient functions should involve only the independent variable or variables. Okay. I hope you get it. If you have any question, you can ask me. Yeah. हाँ, फिर दो रूट्स आ जाएंगे. It will not be a linear equation. Any question? Maybe in the chat window. Yes. yes, in in linear ODEs, the right hand side may be 0 as well. So you can have 0 here. Let me change the camera. It's not change. Camera change नहीं हो रहा यार. इसका चल, no problem. We can erase. There are some shortcuts for uh, looking at the differential equation, whether it is a linear or not linear. For example, which मेरे notes में लिखी हुई हैं, in each term of differential equation, products of y and its derivatives should not be involved. The first property अगर आप कहेंगे तो आप ये देखें, अगर आपके पास d square y by dx square है plus y into dy by dx है plus y is equal to 0 है. So y और इसके derivatives का product नहीं होना चाहिए differential equation में. ठीक है, क्यों? क्योंकि आपके पास यहाँ पे 1 है, यहाँ पे 1 है, तो it becomes as a whole 2. और कोफिशिएंट फंक्शंस में y इन्वॉल्व नहीं होना चाहिए. ठीक है, मींस यहाँ पे अगर इसको आप कोफिशिएंट फंक्शन एज अ कोफिशिएंट फंक्शन ले तो इट इज अ फंक्शन ऑफ y. ठीक है, f of x इक्वल टू x और f of y इज इक्वल टू y. कोफिशिएंट फंक्शंस जो है उसमें दे शुड ओनली इन्वॉल्व इंडिपेंडेंट वेरिएबल्स, नॉट द डिपेंडेंट वेरिएबल. ठीक है, यहाँ पे जो इसके डेरिवेटिव्स या इसके जो कोफिशिएंट्स होते हैं, ठीक है, these are called coefficient. चले मैं आपको जनरल लीनियर पहले ये देख लें. जनरल nth ऑर्डर लीनियर ODE. ठीक है, हम इसको कैसे लिखेंगे? जनरल nth ऑर्डर लीनियर ODE, we can write it in this form: a n of x dn y by dxn plus a n minus 1 of x dn minus 1 y by dxn minus 1 plus so on plus you can come here a2 of x d square y by dx square plus a1 of x dy by dx plus a naught of x y is equal to some kind of function f of x. So this is your general nth order linear ODE. This is how we can write it. You can see here, sorry, in each term, the y is linear, power 1, and the coefficient function, this one is a function of x only. In each term, you can check here. In each term, the dependent variable y has degree 1, and the coefficient function, this one, the coefficient of the derivatives, okay, the dn minus 1 y dxn minus 1, its coefficient function is this one, a n minus 1 of x. It should involve only the independent variable x, which is here, independent variable. Similarly, and so on, a2 of x, second derivative, a2 of x is a function of x only. It should be function of x only. This one as well, this one as well. Here you have power 1, but zeroth derivative, okay? Zero derivative, and the coefficient a naught of x is a function of x only. And the right hand side is also the function of x only. So this is the more general form of the nth order linear differential equation. No, the terms should be linear. they must have power 1, exactly 1. They cannot be half plus half. In that case, y power half is not a linear term. They should have degree 1 in each term. So you cannot write here. Let me give you examples of linear first, and then we'll discuss non-linear. We can write here x square y double dash plus maybe e raised power x y dash minus 3y is equal to 8. This is linear because every term, the coefficient function involves only the function of x. And here we have power 1. Here we have only function of x, degree 1. Here we have degree 1. Okay? So in each term, y has degree 1. That is why we call it linear. Now, you cannot write here y double dash plus y square root of y into dy by dx power 1 by 2 plus y is equal to 0, maybe. So this is not linear. Why? Not linear. Why? Because y has, in this term, the degree of y is 1 by 2 and degree of dy by dx is 1 by 2 and the degree of y is 1 by 2. Okay? It's true that its total is 1, but each term should have degree 1. Okay, the product should not be involved of the dependent variable and its derivatives. Similarly, another example you can see here that if you have y double dash maybe plus cosine of y dash plus y square is equal to 0. Now you can see here that we have y double dash and the coefficient of y dash is cosine of y. So this makes it non-linear because why? Because here you have degree 1. No, we don't have degree here because the cos y is a non-linear function. It's not a linear function. What is a linear function? Whose graph is a straight line. So cosine of y का graph straight line तो नहीं होता ना. So it's not a linear function. टेलर सीरीज की फॉर्म में लिख सकते हैं आप इसको. टेलर सीरीज की फॉर्म में लिखे तो you would have terms of y square, y4 and so on. Similarly, here you can see that here its degree is not 1. It's not linear. So this differential equation as a whole is not linear. Even if you don't have cos y here, you have only cos y here, cosine of y. Now this term is linear, this term is linear, but this term is not linear. Why? Because cosine y is not linear function. If you write it in the form of a Taylor series, then it will involve cosine, it will involve y square, y4 and y6 and so on. So this is again not linear. I hope you get it. If you have any question, G.
Sir, rather than like we had cos y dash, right? If we had cos x y dash, that would be okay.
Yes, then we are okay. Cosine of x y dash, then we are okay because the coefficient function is a function of x, independent variable. We don't look at independent variable. We look at dependent variables while deciding whether this differential equation is linear or not linear. Okay. As long as the coefficient function is a function of x, we don't have any problem with this differential equation or with this term. You got it? Any other question? Okay, let me raise it and define some. In this equation 1, if the right hand side is 0, then equation 1 is called homogeneous nth order linear ODE. Otherwise, it is called non-homogeneous. ODE. आप कह सकते हैं. If the right hand side is 0, then this differential equation will be called what? Nth order linear and homogeneous ODE, ordinary differential equation. In other case, if the right hand side is non-zero, then we call it nth order linear non-homogeneous ODE. Okay. Now, what is the solution of a differential equation? I told you in the previous lecture, I hope, a solution of a differential equation is a function which turns that equation into an identity. Means left hand side and right hand side will become both same. Let me write it for you. What is the solution of a differential equation? And ODE maybe, or you can write generally as well. Solution of a differential equation. Any function phi, यहाँ पे proper definition यहाँ पे notes में लिखी हुई है, you can write it. Any function y is equal to phi of x, okay, where x should be defined on some interval, where x belongs to I and I is a subset of R. In case of ODE. Any function this defined on some interval, open interval I, which is a subset of R, and it possesses at least n derivatives. At least n derivatives that are continuous on I. Which, when we substitute in the nth order differential equation, which when we substitute in the nth order differential equation, reduces that equation or reduces it into an identity. Then we call this function y is equal to phi of x is the solution of that differential equation. Now, this is a definition for the general nth order ODE. Let me explain this to you with the help of examples. If we If you have this differential equation, dy by dx is equal to x square root of y for all x belongs to R. No, this equation is not involved. This is a differential equation. Okay. Let or uh, you can say verify that y is equal to x4 by 16. Define x belongs to R. Verify the function this is a solution of 1. We call it 1. Okay. This is a differential equation. This is a first order differential equation. This is a first order differential equation, and we have to verify that this is a solution of this differential equation. Now, if we assume that this is a solution, it should have derivatives up to order 1, because the highest order derivative involved in this equation is 1. So the solution should be should have first derivative, and that derivative should be continuous as well. Now, if you look at this function, y is x power 4 over 16. If we take its first derivative, it will be 4x cubed divided by 16. And that derivative is also continuous. There are no breaks. Okay, there are no singularities in that function, y dash. So this function is differentiable. Its derivative exists up to order of the differential equation, at least. And that derivative should also be continuous. Then we can say that, and then if we substitute this function into differential equation, and this function turns this equation into identity, then we say that this is a solution of this differential equation. Okay. So if we take its derivative dy by dx, which is 4x cubed divided by 16, and it is x cubed by 4. And it is defined for all x belongs to R. Okay. The same interval, जो कि यहाँ पे है. So its derivative exists and it is continuous on the same interval. Okay. Then if we substitute this into this differential equation, it should turn that equation into identity. So we put this thing on the left hand side, x cubed by 4. Right hand side पे क्या है? X times square root of y. Y is what? 16. इसका square root लेना है हमने. So it becomes x into x squared by 4, which is x cubed by 4. What was the left hand side? It is x cubed by 4. So now this left hand side is equal to right hand side. So this function has turned that equation into an identity. Identity means left hand side is equal to right hand side. So therefore, this is y is equal to x power 4 over 16. Okay, is a solution of given ODE. I hope you get it. If you have any question, you can ask them. Let's try another example.
सर
जी.
सर ऊपर वाली एग्जांपल में हमने देखा कि वो सॉल्यूशन है, लेकिन अभी हमें ये नहीं पता कि ये क्या ओनली सॉल्यूशन है कि यूनिक सॉल्यूशन है कि इसके अलावा भी हो सकते हैं, राइट?
Yes. We are not still looking at whether this is the only solution or unique solution. Okay, we'll discuss these things after this.
Okay, sir. Thank you.
Let's see another example. y double dash minus 2y dash plus y equal to 0, and verify y is equal to x into e raised power x, define on x belongs to R. Okay, is the solution of the given differential equation. Okay, now this is a function, and the order of this differential equation is 2. So this function and its two derivatives, first derivative and second derivative, should be continuous or should exist. Two derivative of this function should exist and they should be continuous on the same interval r. Okay, तो आप इसके दो डेरिवेटिव लें. फर्स्ट डेरिवेटिव क्या होगा? x as it e raised power x का डेरिवेटिव e raised power x plus x का 1 e raised power x as it. So it is e raised power x and 1 plus x. Okay. Now this function is continuous. By looking at this function, we can see that this function is continuous for all x belongs to R. So its first derivative is continuous. It exists and it is continuous. Similarly, you can check the second derivative that should also be continuous. Okay. So its second derivative is what? X e raised power x plus 2 e raised power x. It is also continuous. It exists and continuous on the same interval for all x belongs to R. Now, the two derivatives of this function, they exist and they are continuous on R. Therefore, now the second step, which we need to verify that this function turns this equation into identity. If that is true, then we say that this is a function of this differential equation. This is a solution of this differential equation. Now we put y double dash. You can take left-hand side. Left-hand side of the differential equation is y double dash minus 2y dash plus y. You put y double dash, which is what? It is x e raised power x plus 2 e raised power x minus 2 times what is the first derivative? It is 1 plus x times e raised power x. And what is the first derivative? Plus x e raised power x. Now, after solving it, you should have 0, which is equal to the right-hand side. Now, this function turns this equation into identity. Therefore, this is the solution of the given differential equation. I hope you get it. If you have any question, you can ask. Types of solution next. If you have any question, you can ask me. There are several.
Sir, I am a little confused. Could you please go over the last two lines again?
This one.
Yes, sir.
If you want to check whether this function satisfies this equation, what do? You choose for the left-hand side. You start with the left-hand side, and you must arrive at the right-hand side. This is how we can prove it.
Yes, sir.
How can you prove it? How can you prove that x squared plus x plus 1 is equal to 3? How do you choose? How do you prove? Yeah, when x is 1. Can you prove that this equation is true for x equal to 1? How can you
Yes,
prove?
sir.
You choose
By
left hand
plugging
side.
it in.
हाँ, ये ना left hand side किया आपने, x को आपने 1 put किया, 1 square 1 plus 1, it is 3, which is equal to right hand side. So that is how we prove it. यहाँ पे हम क्या कर रहे हैं? हम ये function को इसमें put कर रहे हैं, left hand side में. Y double dash हमने पहले put कर दिया यहाँ पे, फिर लेफ्ट हैंड साइड हमने चूज की, उसमें y डबल डैश पुट किया, -2 y डैश प्लस y, ये हमने पुट कर दिया. आफ्टर सॉल्विंग इट वी गेट 0, which is equal to right hand side. So this is how we prove an equation for some particular value of y. नहीं समझ आई?
नहीं सर, समझ आ गई. Thank you so much.
We start with the left hand side and we arrive at the right hand side. ठीक है? By
Thank you so much, sir.
plugging in the value of y. Okay, that's obvious, I think. No problem. टाइप्स ऑफ सोल्यूशन, ये तो हो गया कि सोल्यूशन होता क्या है. व्हाट इज द सोल्यूशन ऑफ अ डिफरेंशियल इक्वेशन? नाउ देयर आर सेवरल टाइप्स ऑफ सॉल्यूशंस ऑफ अ डिफरेंशियल इक्वेशन. Number one is the trivial solution. Trivial solution. Trivial solution, or you can say zero solution. कोई भी डिफरेंशियल इक्वेशन है, फॉर एग्जांपल अभी हमने जो देखी थी y डबल डैश माइनस 2y प्लस वाई इक्वल टू 0, ये है ना. एक तो सोल्यूशन हमने कहा कि x इक्वल टू x, y इक्वल टू e रेज़ पावर x इनटू e रेज़ पावर x, ये सोल्यूशन. ठीक है. अनदर सोल्यूशन, अगर y इज इक्वल टू 0 इसमें पुट करें तो ये इस इक्वेशन को आइडेंटिटी में कन्वर्ट करता है ना. y is equal to 0 इसमें पुट कर दे तो 0 0 0, so this equation becomes 0 is equal to 0. ठीक है. अगर if we insert this solution y is equal to 0 here, what we obtain, 0 plus 0 plus 0, yeah, 0 minus 0 equal to 0, which returns this equation into identity. 0 is equal to 0. So what does it mean? This is another solution of this differential equation. Okay. So if y is equal to 0 satisfies the given differential equation, then y is equal to 0 is called a trivial solution or zero solution of the differential equation. ठीक है. ये हमेशा homogeneous ODEs के लिए एग्जिस्ट करता है. अगर आपके पास नॉन होमोजेनस हो, मसलन अगर मैं यहाँ पे पुट कर दूं y डबल डैश माइनस 2y प्लस वाई इज इक्वल टू सम फंक्शन x स्क्वायर प्लस 1. Now y is equal to 0 is not a solution. ठीक है. y is equal to 0 आपका solution नहीं है, because y is equal to 0 पुट करें 0 minus 0 plus 0, this is not equal to x square plus 1. So this is not a solution of this differential equation. In that trivial solution is the solution we y is equal to 0, we assume it. ठीक है. अगर y is equal to 0 इस इक्वेशन को सेटिस्फाई करता है तो इसको हम trivial solution कहेंगे. Now another question was posed by another student, whether this equation has a unique solution. No, it has two solutions. Okay. A differential equation can have more than one solutions. Okay. For example, this equation has this solution as well as this is another solution. So a differential equation can have more than one solution. उसके भी हो सकते हैं. ठीक है. A non-homogeneous linear or non-linear, whatever that differential equation is, that can have more than one solutions. ठीक है. In fact, we'll discuss infinite many solutions, one parameter family of solutions, and so on, which we discussed already in linear algebra. Some of the topics of this course, they overlap with the MATH210, linear algebra with differential equations. Okay. But recently we have introduced another course of pure linear algebra. Now SSC students will have choice to either take MATH210 or the other course of pure linear algebra. There'll be no differential equation along with the linear algebra. Okay. So it's a trivial solution. Next is one parameter family of solutions. Okay. One parameter family of solutions of an ODE of a differential equation. What is this? Now, if you have a first order differential equation, first order ODE, for example, or differential equation, whatever it is. It is true for differential equation as well, PDE as. Okay. A first order ODE can be written in the form dy by dx is equal to f of xy. ऐसे लिख सकते हैं, ठीक है? Or more generally, you can write it in this form x, y, y dash equal to 0. ठीक है? In this differential equation, what is our purpose? Our purpose is to solve this differential equation. Means you have to find a function y in terms of x, and that function should satisfy this differential equation. Okay. And that function y is equal to phi of x, and x should be defined on some open interval I, which is a subset of R. Now, from this equation, how can we arrive at y? Here we have dy by dx, and here we have fxy. Okay. So if we have one derivative in the equation, how can we eliminate that derivative from that equation?
So
What is the,
integrate.
yes, we have to integrate. So we have to integrate this expression or this equation once in order to go back to get the value of y. Okay. If you integrate a function once, improper integrals, आपने proper and improper integrals पढ़े होंगे calculus में. Improper integral, because there are no limits here. While doing integration on both sides here, in order to get y, you must have a constant of integration after doing the integration of this equation. ठीक है? किसी भी function को integrate करें, you must have to introduce a constant of integration in that expression. Am I right? So after integrating it, if we integrate this equation or equation 1, आप इसको कह रहे हैं equation 1. If we integrate equation 1, we should get, or we must get, we should obtain some kind of expression g of x, y, comma, some constant. We put it equal to 0. Okay. Or in some books, they put it equal to some constant c. So after integrating that equation, you get a function x, g of x, y equal to some constant c. Okay. Sometimes in books they write in this way or in this way. Now, what is this c? This is a constant of integration, which we might have lose while doing the differentiation in order to obtain this differential equation. Okay. So we introduce that constant c here after the integration of this equation in order to eliminate this derivative. ठीक है? एक derivative है तो एक दफा integration होगी, एक constant of integration आएगा. ठीक है? So that constant is the c. We usually say that the c belongs to R. Okay? C could be any real number. Okay? That is a constant which may change its values. It is usually called parameter. Okay? So that is why we call it. Now, how many solutions of this differential equation we will get after integrating this equation? If we have this parameter can have infinite many values. So how many solutions are these? These are infinite many solutions. It is not a single solution, it is a family of solutions, family of similar kind of solutions. Okay, so that is why we call it is one parameter family of solutions. family of solutions, because we will have one solution for every particular value of C. So how many values of C we can take here? We can take infinite many values. So it is infinite many solutions, and we call it one parameter family of solutions. Why we call it family? Because all the solutions would be of same type. Okay. Let me give you an example of this thing. Uh, yeah. The function y is equal to x plus c whole square is a one parameter family of solutions of the differential equation is what? It is the differential equation is dy by dx whole square is equal to 4y. So this is your differential equation, and this is your one parameter family of solutions. Okay. Now, why we call it a family? Because this is nothing but this is a function y is equal to x plus c whole square. And how can we write it in general? We can write it in general. It's a function of x, y, and c, and we put it equal to 0. Okay. How can we write it? We can write it in this form: y minus x plus c whole square is equal to 0. So this whole thing becomes this g of x, y, and c. Okay. Now, if we plot it, we draw its solution on xy plane. आपके पास solution क्या है? Y is equal to x plus c whole square. Now, if we put c is equal to 0, what is this function? This y is equal to x square. Okay. So if we choose y is equal, sorry, c here, c is equal to 0 here, 0, then the solution is of this kind. Y is equal to x square. Now, if you choose x equal to c is equal to 1, c को आप 1 ले ले, तो फिर क्या होगा? राइट हैंड साइड पे शिफ्ट होगी या लेफ्ट हैंड साइड पे? लेफ्ट पे शिफ्ट हो जाएगा solution. So it would become a kind of this thing. अगर c की वैल्यू -1 रखें, नहीं, अगर हम c की वैल्यू -1 रखें तो राइट हैंड साइड पे शिफ्ट हो जाएगा, यहां पे आ जाएगा सोल्यूशन. ठीक. अगर हम यहां पे c की वैल्यू -2 रखें तो सोल्यूशन यहां पे शिफ्ट हो जाएगा. ठीक है. सो इसी तरह यहां पे c की वैल्यू अगर आप -2 रखेंगे, सॉरी +2 रखेंगे, तो सोल्यूशन यहां पे -2 पे शिफ्ट हो जाएगा. ठीक. Now these are some particular values of c. c की वैल्यू अगर 0 है, c की वैल्यू अगर यहाँ पे -1 है, c की वैल्यू अगर -2 है, यहाँ पे c की वैल्यू 1 है, c की वैल्यू 2 है. ठीक है. And so on, you can choose other values of c. ठीक है. How many solutions do you have? You have infinite many solutions of the similar kind, exactly same kind of solution. ठीक है. So अब अभी तो हमने c की वैल्यू सिर्फ इंटीजर्स ली हैं. c की वैल्यूज डेसिमल में तो होंगी ना, डेसिमल में भी होंगी. अगर c की वैल्यू आप 0.1 ले लें तो यहां पे सॉल्यूशन शिफ्ट हो जाएगा यूं. ठीक है. इसके दरमियान 0 और 0.1 के दरमियान c की कितनी वैल्यूज है? इनफिनिट मेनी. सो 0 और 0.1 के दरमियान इनफिनिट मेनी सॉल्यूशंस होंगे. सो वी हैव अ फैमिली ऑफ जैम पैक्ड सॉल्यूशंस. ठीक है. अगर आप c की सारी वैल्यूज को काउंट करें रियल नंबर पे, तो इट्स काइंड ऑफ ये सारा फिल हो जाएगा. इसमें कोई खाली जगह बचेगी नहीं, क्योंकि सब जगह कर्व्स आ जाएंगी ना, लेकिन कर्व्स किस टाइप की होंगी, इस टाइप की होंगी. So we have infinite many or uncountable kind of solutions, which is a family of solutions, one parameter family of solutions. अगर आपके पास फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन हो, ठीक है, अगर आपके पास सेकंड ऑर्डर डिफरेंशियल इक्वेशन हो, then from the second order derivative which is involved in that equation, we have to go back to y. G. Ahmed Nadeem, ask your question.
Sir, the first order differential equation है ना, but you could also add another constant y के अंदर, और फिर एक दो पैरामीटर्स हो जाएंगे, but it's still a first order differential equation.
No, यहाँ पे आप क्या
तो
कह
मतलब
रहे
अगर आप
थे,
ग्राफ को ऊपर नीचे
x में भी
शिफ्ट कर,
किसको शिफ्ट करें,
एंड पे एक और कांस्टेंट ऐड कर दें t, तो ग्राफ को ऊपर
we
नीचे
cannot
ग्राफ शिफ्ट करें.
we cannot add any constant by ourselves. It's a
लेकिन
constant
वो
which comes from the mathematical manipulation or interpretation while solving the
yes sir,
differential
लेकिन
equation.
अगर मैं एक 5 खुद ही क्रिएट करूं, it's
हाँ,
still a solution to the differential equation.
अगर आप if you add another constant here, then it will not be a solution of that differential equation. It will not be a one parameter family of solution of that differential equation. That you would obtain something different. ठीक है,
तो अगर आप
आप
n पे भी कांस्टेंट ऐड करो, so x plus c whole squared plus k.
यहाँ पे, ठीक है,
Yes sir.
but you cannot add it. But अगर आप ऐड करते हैं for the time being, then आपके पास solution में vertical shift भी आ जाएगी, लेकिन that will
Yes sir.
still give you infinite many solutions. Infinite many का infinite many तो कुछ भी नहीं होता ना, that remains infinite many. But
Yes
you
sir,
cannot
अब 2 पैरामीटर है
add,
ना.
हाँ, अब 2 parameter हो जाएगा, but there are no 2 parameter solutions of first order differential equation. 2 parameter family of solution can be obtained from the second order differential equation. अगर आपके पास second order differential equation है जिसमें second
Okay, sir.
derivative involved है, then in order to go back from the second derivative to the original function y, we have to integrate it 2 times.
Right sir, so तो इसको हम कंसीडर नहीं करेंगे ना एज अ सॉल्यूशन टू दिस.
नहीं इसको
So
नहीं
even
करेंगे.
though इसका डेरिवेटिव लें तो वो इक्वेशन को satisfy आइडेंटिटी बना देगा.
हाँ, even then we cannot take it as a solution of that differential equation, but it cannot make that equation identity. That is sure. ठीक है, तो 2 parameter family of solution क्या होगा, वो second order differential equation के लिए होगा. अगर आपके पास second order differential equation है, second order यहाँ पे second, उसमें आपके पास 2 parameter family of solutions होंगे, क्योंकि आपके पास d square y by dx square है, ठीक है, which is a function of x y y dash. So this is your equation now. You have first derivative, you have y, you have second derivative in this differential equation. In order to go back, in order to obtain this y as a function of some variable x, okay, you have to integrate this equation 2 times. Okay, you have to integrate this equation 2 times. So that must involve 2 parameters. G of, we must obtain g of x, y, c1 and c2 equal to 0. Okay, so this will be a 2 parameter family of solutions. Okay. For example, let me give you a similar kind of example. यहाँ पे जो हमने की थी, अगर आपके पास यहाँ पे एक इक्वेशन है y double dash minus 9y plus 9y is equal to maybe 0, then y of x is c1 sine 3x plus c2 cosine 3x. You can prove that this is a solution of this differential equation. Okay, let me verify कि मैंने equation और solution ठीक लिखा है, तो ये solution नहीं होगा इसका. हाँ, ठीक है, where c1 and c2 they belongs to R. Now you have 2 parameter family of solution, because this as a whole can be written as g of x, y, c1 and c2 is equal to 0. There are two parameters c1 and c2. And after solving this, we get this solution, which involves two parameters c1 and c2. So this is why we call it two parameter family of solution. अब आप इसमें अगर c1 और c2 की values vary करें तो आपके पास scale up, scale down and बहुत कुछ हो जाएगा. Basically आप इसको C1 को और इसको कंबाइन करके यूजिंग सम ट्रिग्नोमेट्रिक आइडेंटिटी इसको साइन या कॉस में कन्वर्ट कर सकते हैं. उसका एम्पलीट्यूड और बहुत सारी चीजें आ जाती हैं उसमें. बहरहाल इसको हम बाद में डिस्कस करेंगे. So this is a two parameter family of solution. And similarly, if you have an nth order differential equation, then in general an nth order differential equation, nth order differential equation क्या होती है? dny by dxn is equal to f of x, y, y dash, so on, yn minus 1th dash. This is your nth order differential equation, and its solution should involve x, y, c1, c2, so on, cn equal to 0. Means it should involve n parameters. And all of these parameters, they should belongs to R. This is called n parameter family of solutions. You can read this definition from my notes. If you have any question, you can ask me. The next thing which we wanted to discuss is the particular solution. पहले हमने trivial solution देखा, फिर हमने n parameter family of solutions देखे. अब हम देखते हैं what is the particular solution. Number 3 is particular. अभी हमने कहा कि किसी भी फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन का जो सॉल्यूशन होता है उसमें एक पैरामीटर इन्वॉल्व होता है. ठीक है, जैसे कि हमने कहा कि y is equal to x plus c whole square is a solution of y dash square is equal to what? अभी हमने लिखी थी ना, यहाँ पे रेस कर दी थी.
4y.
हाँ, y dash whole square is equal to 4y. It was y dash whole square is equal to 4y. ये यूं कह सकते हैं. ठीक. This is a solution of this differential equation. Still, we are not discussing how to find the solution. We'll discuss it later on. But you can verify that this is a solution of this differential equation. Okay? Now it's a one parameter family of solution. Particular solutions क्या होंगे? A particular solution is a solution which can be obtained from by assigning a particular value to C in this one parameter family of solution. ठीक है, that अगर आप C की वैल्यू 0 ले लें तो आपके पास एक solution आ जाएगा which is x square. आप C की वैल्यू 5 ले लें तो आपके पास एक और solution आ जाएगा which is x plus 5 whole square. ठीक है, all these solutions are called particular solutions. ठीक है. अच्छा, एक और बात which I forgot to tell you, in one parameter family of solution, one parameter family of solution उसको हम कैसे लिखेंगे? We can write it in this form, g of x, y, and c is equal to 0. A solution of first order differential equation which involves one constant is called a general solution. ठीक है, one parameter family of solution भी कहेंगे इसको, और इसको हम जनरल सॉल्यूशन भी कहेंगे. ठीक है, जनरल सॉल्यूशन. ठीक है, सो अ जनरल सॉल्यूशन. इसी तरह सेकंड ऑर्डर ओडी अगर आपके पास टू पैरामीटर फैमिली ऑफ सॉल्यूशन आता है तो इसको भी हम एज इन जनरल इसको हम जनरल सॉल्यूशन भी कहेंगे. ठीक है, इसी तरह थर्ड ऑर्डर nth ऑर्डर ओडी है, इसमें इसका जो सॉल्यूशन जिसमें n पैरामीटर्स हैं इसको हम जनरल सॉल्यूशन भी कहते हैं. ठीक है, अच्छा, any solution which can be obtained by assigning particular values to the constants, okay, that solution is called a particular solution. Okay. एक और होता है which is called singular solution. So आप कोई भी वैल्यू यहाँ पे c की रख लें, particular solution आपके पास particular solution आ जाएगा which can be obtained from the general solution by assigning some specific values to those parameters. ठीक है, तो इसको हम particular solution कहेंगे. Singular solution क्या होता है? Singular solution is a solution which cannot be obtained from the general solution. Okay, singular solution अगर आपके पास कोई भी डिफरेंशियल इक्वेशन है, मसलन आपके पास y डैश इज इक्वल टू x स्क्वायर रूट ऑफ y, ये एक डिफरेंशियल इक्वेशन है, इसका सॉल्यूशन हमने लिखा था y इज इक्वल टू y ऑफ x इज इक्वल टू x स्क्वायर बाय 4 प्लस c होल स्क्वायर. ठीक है, अब ये इक्वेशन है, इसका वन पैरामीटर फैमिली ऑफ सॉल्यूशन ये है. ठीक है, या जनरल सॉल्यूशन ये है. अगर इसमें हम c को 0 पुट करें, we'll get a particular solution. ठीक है, it is a particular solution जो कि हमने पहले लिखा था while doing this example. ये एक particular solution है, लेकिन इसी इक्वेशन का y is equal to 0 भी solution है, which is a trivial solution. trivial solution है ना इसका ये. अगर y 0 पुट करें तो दोनों इक्वेशन, दोनों साइड्स इक्वल हो जाती हैं. Can you obtain this solution by assigning some specific value to c here from r? c की कोई भी वैल्यू r को, क्योंकि c r को बिलोंग करता है ना, c belongs to r. ठीक है, can we obtain this solution by assigning some particular value to c from r? Can we obtain this? No. So a solution which cannot be obtained from the general solution by assigning some specific value to that parameter or parameters, then this kind of solution is called a singular solution. I hope you get it. If you have any question, you can ask. There are other examples to singular solutions as well. You can see them. मसलन ये एक और एग्जांपल गिवन है यहाँ पे. Y dash whole square minus 3x y dash minus y is equal to minus 3x square. ठीक है, and its general solution y of x is cx plus x square plus c square. ठीक है, और y is equal to x is equal to 3 by 4 x square. ये इसका singular solution. This is a singular solution to this differential equation, and this is a general solution, which is a one parameter family of solution. Can we obtain this solution out of this solution? No, we cannot obtain this one because here we have x square का coefficient 1 है, ठीक है, whereas यहाँ पे x square का coefficient 3 by 4 है. So we cannot obtain this solution from this solution by assigning some specific value to c from r. Then this is a singular solution to this differential equation. So a differential equation, now the answer to that question, can a differential equation have infinite many solutions? Yes. A differential equation can have infinite many solutions. ठीक है, क्यों? ये तो इसमें तो चले पैरामीटर है ना, पैरामीटर है इसमें, पैरामीटर है, जिस पैरामीटर को वैल्यूज को आप वेरी करें तो आपके पास इन्फिनिट मेनी सॉल्यूशंस आते हैं. लेकिन देयर आर अदर सॉल्यूशंस टू दैट similar same differential equation which are singular solutions. Ab singular solution, it is not mandatory that there is only one singular solution. There might be other singular solutions as well. Okay, this is what we have found yet. ये तो अभी हमने find किया ना singular solution. There might be other solutions which are singular solutions as well. So a differential equation can have infinite many solutions. Okay. If you have any question, you can ask me. Otherwise, we are going to stop today here. I'm available for any questions. So if there are no questions, let us stop with today here and see you next time, inshallah, in the next week.
Allah Hafiz.
Okay, Allah Hafiz.